All right, so we've seen two types of factoring already. We've factored out the GCF and we've also factored by grouping. So now we're going to look at quadratics. If we have a quadratic, we're going to use a method called the AC method. And so before we look at that third method for factoring, let's take a look at what we already know, which is multiplying a binomial times a binomial. And so I have 2x plus 3 multiplied to the x plus 2. So if you're foiling or if you're distributing, you're going to multiply the 2x to the x plus 2. And that gives you 2x squared plus 4x. And then you're going to distribute the 3 to the x plus 2. And so that gave you 3x plus 6. And then if you combine your like terms, which is 3x and 4x, you end up with 2x squared plus 7x plus 6. And this 2x squared plus 7x plus 6, this is a quadratic. Now, how would we reverse this? Okay, that's the question. How would we unmultiply this? And that is going to be the basis of this lesson, this idea of factoring these quadratics, which we're going to do with a method called the AC method. So the first thing we're going to do, starting with 2x squared plus 7x plus 6, the first thing we're going to do is identify the coefficients a, b, and c. A, we know, is equal to 2. B is equal to 7. And C is equal to 6. All right. When you do the AC method, you're going to first start with multiplying your coefficient A multiplied by your coefficient C. A times C, in this case, is 2 times 6, gives us 12. And so we want to look to see, okay, what factors when multiplied give us 12? Well, there's a number of them. 1 times 12. 2 times 6. Oop, that doesn't look like a very clear 3. 3 times 4. Okay, now we're not going to use all of those. From this list, then you want to take a look to see, okay, your sum is going to equal to B. B is equal to 7. So which of these has a sum of 7? We know 1 plus 12, that equals 13. That's not it. 2 plus 6, that equals 8. That's not it. 3 plus 4, well, there we go. That equals 7. Okay, so this is helping us figure out how to break down our problem so that we can reverse the multiplication. In other words, so that we can factor 2x squared plus 7x plus 6. So now that I have 3 and 4, I am going to use this 3 and 4 to rewrite my polynomial here, my quadratic. I'm going to rewrite the term 7x. Instead of 7x, I'm going to write that as 3x and 4x. So we get 2x squared plus 3x plus 4x plus 6. Now you can see immediately 3x and 4x indeed equals 7x. Perfect. We are on our way to factoring this quadratic. Now that we have rewritten this, now we are going to factor by grouping. There you go. So I am going to use 2x squared plus 3x as my first group And I can see between those two terms, my GCF is x. All right, so remember, you're going to take the 2x squared and you're going to divide it by x. And you're going to take the 3x and you're going to divide it by x to get your second factor. So 2x squared divided by x is 2x plus 3x divided by x is 3. Perfect. All right, now let's take a look at the second group, 4x plus 6. So our GCF is 2. So we want to divide the 4x by 2 and the 6 by 2. So 4x divided by 2 is 2x plus 6 divided by 2 is 3. All right, perfect. And that is what we wanted. We wanted to get another GCF. So now we're going to factor again. We're going to factor out the 2x plus 3. And so if I divide my first group by 2x plus 3, what am I left with? 1x. And if I divide my second group by 2x plus 3, what am I left with? Plus 2. So my second factor is x plus 2. All right, and you can see here we have factored the quadratic. We have unmultiplied this polynomial. All right, and if you want to check it, you can always check your answer by actually multiplying, which is, we already did that from the start. Okay, now that you've seen the process, let's do it again. All right, so we have factor 10y squared plus 17y minus 20. Okay. So I have here on the left, the first question you need to really ask yourself, do we have a GCF that is not 1? Because if we have a GCF to factor out from the beginning, we should factor it out now, but we don't. The GCF of 10y squared plus 17y minus 20 is just 1. So answer to the first question is no. We're going to move on. Now we're getting ready for our AC method. So let's identify our values for our A coefficient, our B coefficient, and C coefficient. A equals 10. B equals 17. C equals negative 20. So A times C, 10 times negative 20, right? So that gives us negative 200. And for our sum, B has to equal 17. So I already know, since my sum has to be a positive number, when I'm writing my factors, the bigger number is going to be positive. And so here we go. I'm going to start with negative 1 times 200. That's not it. Negative 1 plus 200 is not 17. Okay, negative 2 times 100. That's not it, because negative 2 plus 100, not 17. Let's keep going. Negative 3, it's not going to be a factor, so let's see, negative 4 times 50. That's still not it. Negative 4 plus 50, not 17. How about negative 5 times 40? I think we're getting closer, but still not it. Negative 5 plus 40, not 17. All right. Negative 6 is not a factor. Negative 7 is not a factor. Let's do negative 8 and 25. I think we might have it. Let's see. Negative 8 plus 25, that is positive 17. Perfect. So this is what we are going to use to factor our quadratic. So now we are going to rewrite the quadratic as 10y squared. And then remember, the plus 17y is what's being rewritten. So we have minus 8, so that's minus 8y. And we have positive 25, so plus 25y. And then bring down the minus 20. And now we can factor by grouping. So I'm going to take the first two terms as a group. 10y squared minus 8y. The GCF of that between 10 and 8 is 2. And then y squared and y, so we just have y. So divide this by 2y and this by 2y. So 10y squared divided by 2y gives us 5y minus 8y divided by 2y is just 4. Okay, our second group, our GCF, it looks like it's 5. So I'm writing plus 5 divided by, so we're dividing 25y by 5 and minus 20 by 5. So what do we get? We get 5y minus 40. Perfect. Right? We got another factor that's in common. So factor again. We're factoring out the 5y minus 4. Okay. So if we do that, we are left with 2y plus 5. We have factored our quadratic. Now, it's always a good idea to check your work by multiplying. Okay, so I'm going to check my work. We have the 5y minus 4 multiplied to the 2y plus 5. So if we FOIL or if we distribute, I'm going to draw my arrows in there. 5y to the 2y, that's 10y squared. 5y to the 5, that's plus 25y. Minus 4 to the 2y, that's minus 8y. And then minus 4 to the 5 is minus 20. So combining your like terms, we get 10y squared plus 17y minus 20. And that is exactly what we started with. And so I feel really good about our answer. Let's do it again. All right, we have factor 8 minus 22x plus 5x squared. Now, before we're off to the races, first thing I want to point out is it's highly recommended that you start with writing your answer in standard form. So that's what we're going to do. We're going to write this in standard form. So that means I'm going to put the 5x squared first, minus 22x second, plus 8 third. Wonderful. So now I'm going to ask myself, do we have a GCF that is not 1? No. Okay. Next, let's identify A, B, and C. Okay. A, 5. B, negative 22. C, 8. All right, so our factors multiply to 5 times 8, which is 40. And our sum has to be negative 22. Okay. So, because our sum is negative, I know that I need to multiply two negative numbers here in order to get a positive 40. So I do -1 and -40 to start. That is not going to give us the sum that we want. -1 plus -40 is -41. Not what we want. Next, -2 times -20. All right, that gives us +40. -2 plus -22. That's exactly what we want. So we found the winner. Okay. So now we need to rewrite our quadratic, our polynomial. So we get 5x squared. Now we're rewriting the -22x as minus, and then a 2x, and then minus 20x plus 8. And I see I have a mistake over here. I wrote -2 plus -22. Sorry about that. It's -2 plus -20. All right, let's keep going. So we have our 4-term polynomial. Now we're going to factor by grouping the first 2 terms. The GCF is x. If I divide each of those 2 terms by x, we get 5x minus 2. Okay, now the second group. Because it's leading with a -20, I'm going to factor out whatever my GCF is. I'm going to factor out a negative, whatever the GCF is. And it looks like it's 4. So I'm going to factor out -4 and see if that is what we need. So if I divide each of those by -4, -20x divided by -4 is a +5x. And then +8 divided by -4 is a -2. So we definitely needed to factor out a -4 as opposed to a +4, so that we actually did get matching factors here. All right, we got to factor again. So I'm factoring out the 5x minus 2, right? Some of you might be wondering, do we have to write the divide by 5x minus 2 every time? No, I like to do that just so you can see it. But if you if you can visualize it, you can see if you're factoring out the 5x minus 2, you're left with the x minus 4, which is this and that. And so there's our answer as before. You can check your work by multiplying. So if we have here, I'm going to put the work right underneath. 5x minus 2 multiplied to the x minus 4. So if I distribute there and there, and then here and here, I get equal to 5x squared minus 20x minus 2x plus 8. And then when you combine like terms, you get 5x squared minus 22x plus 8. And we can see that that is what we started with. All right, let's try another one. All right, so you can already see this is not in the standard form. So I want you to go ahead and put this in standard form and factor this, and then we'll do it together. All right, so let's start with standard form. So if we have 5x squared minus 2 minus 9x, standard form will be 5x squared minus 9x minus 2. Now, do we have a GCF that is not 1? Nope. So we're going to keep going. Okay. A is 5, B is -9, C is -2. So A times C, that gives us -10, and B is -9. Okay, so let's take a look at factors. Since my sum is negative, when I'm multiplying, I get a negative. I know I have to have one number positive, one is negative, but the bigger number is going to be negative. So I'm going to do 1 times -10. All right, if I add that 1 plus -10, up my very first one, I got exactly what we need to factor with. 1 and -10. Perfect. So the -9x, we're going to be rewriting that with 1 and -10. So we get 5x squared plus 1x minus 10x minus 2. Okay, factor by grouping. So starting with the first two terms as a group, I'm going to factor out an x. So dividing each of those by x, I'm left with 5x plus x divided by x is 1, folks. It is 1. Second group, I'm leading with a minus 10x. So I'm thinking I probably should factor out a negative GCF, which looks like it's going to be 2. So I'm going to try -2. So if I do that, I get minus 2 parentheses. Negative 10x divided by -2 is positive 5x. And then -2 divided by -2, so we get plus 1. That's exactly what we needed. All right, factor again. Factoring out the 5x plus 1. There's our first factor. So our second factor is x minus 2. Love it. All right. Now, did we do it right? Well, let's see. Let's check our work by multiplying. 5x plus 1 multiplied to the x minus 2. I'm going to use my arrows to show what I'm doing. 5x to the x is 5x squared. 5x to the minus 2 is minus 10x. 1 to the x is plus 1x. 1 to the minus 2 is minus 2. Combine your like terms. We get 5x squared minus 9x minus 2. And that's exactly what we wanted. Perfect. So I'm feeling good. All right. So when you're factoring, this is just a little cheat sheet for your signs. Okay. When you have a quadratic, that is the signs for throughout plus and plus here. And of course, we're going to assume our A values are always positive. Okay, if it's not, we're actually going to factor out a negative something. All right, so plus and plus, when we're factoring, we're getting plus and plus here. Okay, now if we have minus and plus, when we're factoring, we get minus minus. And the reason that is because when you do the -2 times the -4, that gives you that positive 8. But we need the two negatives to get a positive 8, but a negative middle term. Okay, now when you have plus and minus or minus and minus, so essentially your C term is negative, you're going to get one of each when you factor, a plus and a minus. So this might be helpful as you get more comfortable with factoring. Okay, here we go. Pause the video, try this on your own, then we'll do it together. Okie dokie. So we're in standard form for a quadratic. Here, it's even though we have multiple variables, oftentimes, since we have two, you have your exponents going down in one direction. So you have x squared, x to the first power, and then no x in the third term. And then going in the opposite direction, we have y squared, y to the first power in the middle, and then no y. Even though each of these has a degree of 2, it's standard to write it this way when you're factoring a quadratic. So, do we have a GCF that is not 1? Oh, I hate when I do that. Come on. No. All right, A, B, and C. A, 15. B, 16. C, 4. Okay, A times C. We get 15 times 4, so we get 60. And then our sum has to be our B value, which is 16. All right, so we have positives throughout here. So we're working with positives throughout. So you can start with 1 times 60. You don't have to. You can start with what you think is going to work. I'm going to start with 4. So if we do 4, right, multiplied by 15, that's not going to be what we want, but we're close. I know it because 4 plus 15 is 19, which is near 16. What if we did 5? 5 times 12, 5 plus 12, that's even closer, that's 17, so 6. 6 times 10. All right, 6 plus 10 is 16. That's exactly what we needed. So notice I did not start with 1 times 60. I just jumped straight to what I thought was getting me closer to where I needed to go. So now let's rewrite this quadratic by rewriting that middle term, 16xy. So we're going to do 15x squared and then plus 6xy plus 10xy plus 4y squared. Okay, factor by grouping. The first two terms give me a group. My GCF is 3x. Factoring out a 3x. So if I divide this by 3x and the 6xy by 3x, that gives me 5x plus 2y. Keep going. Second group, factor out the GCF. Looks like it's 2y. So factor 10xy by 2y and 4y squared by 2y. And what does that give me? It gives me 5x plus 2y. Factor again. Factor out the 5x plus 2y. And our second factor is 3x plus 2y. Done. But is it right? Well, check your work by multiplying. So, if I take the 5x plus 2y, multiply that by the 3x plus 2y, so distribute throughout, and that gives me 15x squared plus 10xy plus 6xy plus 4y squared. Combine your like terms, so that gives us 15x squared plus 16xy plus 4y squared. All right, does that match what we had in the beginning? It does. All right. Now let's take a look. We have factor x squared minus 12x plus 35. Now you're going to really like these because these have shortcuts. Okay, so here we go. We're in standard form. Do you have a GCF that is not 1? No. Let's keep going. So A, B, and C. A equals 1. B equals negative 12. And C equals 35. Okay, so A times C is 35. And our sum has to be negative 12. So I need two negative numbers when I'm multiplying. So negative 1 and negative 35. That's not it. Negative 1 plus negative 35 is not negative 12. All right, next, negative 5 times negative 7. Okay, negative 5 plus negative 7 is negative 12. Now, whenever our A value is equal to 1, we can shortcut the AC method. This is really nice. These two numbers here, negative 5 and negative 7, is exactly what we need to factor. It's just our first factor is going to be x minus 5. Our second factor is going to be 1x minus 7. Now, you might be in disbelief. Does that really work? Well, if you're in disbelief, let me convince you. Okay? So, previously we were rewriting this by rewriting our middle term. So we would have done x squared, and then we would have done minus 5x minus 7x plus 35. Factor our first group. I'm going to factor out an x. So if I divide those two terms by x, I get 1x minus 5. The second group, I'm going to factor out a minus 7. And so, again, I get 1x minus 5. Factor again. X minus 5 times x minus 7. As you can see, the AC method is going to give you the same thing, but why not take advantage of this shortcut, right? All right, so that is only when A equals 1. Okay, and as always, check your work by multiplying. Okay. We have here x squared plus 7x plus 12. All right, go ahead and factor that. Pause the video, then we will do it together. All right, so I hope that you used the shortcut for this. So we can see we do not have a GCF that is not 1. We do have A is equal to 1. Love that. B is equal to 7. And C is equal to 12. All right, so now 1 times 12. A times C is 12. And our B is going to be 7. So let's see. 1 times 12. That's not what we want. 2 times 6, 2 plus 6 is not what we want. 3 times 4, 3 plus 4, that is exactly what we want. Maybe you didn't do all of those and you went straight to the 3 times 4 because you saw it immediately. No worries, that's great. Okay, so if you used the shortcut, you would see immediately this factors into x plus 3 times x plus 4. But if you're still in disbelief, we can go ahead and do the long way. So we have x squared plus 3x plus 4x plus 12. Factor by grouping, my first group, x squared plus 3x, factor out the x. So when I divide x squared by x and 3x by x, I get x plus 3. Plus, second group, factor out a 4. So when I divide by 4, I get x plus 3. Factor again, x plus 3 times x plus 4. Exactly what we got when we used the shortcut. Alrighty.